continuing on with the lesson, I'm just going to talk to you guys about logarithmic scales, and more specifically about three of the different types of logarithmic scales that we will be doing some calculations for in this lesson. Well, logarithmic scales are basically, they provide us a convenient method of comparing values that are extremely large, and we are going to be focusing on three different scales. The first one, pH scale, the second one is Richter scale, and the third one is decibel scale. And oftentimes when we're comparing concentrations on each one of these scales, we will need to determine the quotient between the values that we're comparing. And I'll show you that through examples that we're going to look at. Perhaps some of these scales you probably already have looked at in chemistry or in your physics classes. So I'm going to start off with the pH scale. The pH scale is basically a scale that is used to determine how acidic or basic a substance is. And generally we can compare that by calculating the concentration of our hydronium ions. So pH scale is defined as pH equals to negative log times the concentration of hydronium ions. So sorry, not times, it's negative log of the concentration of hydronium ions. And this right here is basically just a list of what each one of those whole numbers on a pH scale means, and some of the basic substances that you would see in your household, what type of pHs they have. Just to let you guys know, a pH of 7 is when a substance is neutral. A substance starts increasing in its acidity when pH decreases from 7 all the way to 0. And the substance starts increasing in its basicity when the pH is greater than 7, all the way up to 14. So the scale basically runs from 0 to 14. Okay, so we're going to start off by doing some pH calculations. So first question here is find the pH for tomatoes if the hydrogen ion concentration, which is a hydronium ion concentration, is equal to 6.3 times 10 to the power of negative 5 moles per liter. I'm just going to do the solution at the bottom here just so that I have more space. Okay, equals. So I'm just going to write down what is it that I'm given. So right now I'm given the concentration of my hydronium ion, and that is equal to 6.3 times 10 to the power of negative 5 moles per liter. And I'm asked to figure out the pH. So I'm going to start off by writing down the formula for my pH. So pH is equal to negative log times the concentration of my hydronium ions. I'm just going to plug that concentration in with the value that I'm given. So it's negative log of 6.3 times 10 to the power of negative 5. And I'm just going to go ahead and use my calculator to evaluate that. So I'm going to bring my calculator over here. I'm just going to press negative log 6.3 times 10 to the power of, so times 10, negative log of 6.3 times 10 to the power of negative 5. I'm not too used to using this calculator actually. And value happens to be, you guys can see right here, it's 4.2. So my pH value is going to be 4.2. Okay, and the second part of the question is if the pH of seawater is 8.5, determine the hydrogen ion concentration. So in this case, I am given the pH value, which is 8.5, and I'm asked to figure out the hydrogen ion concentration. I'm going to go ahead and use the exact same formula as we did earlier. So pH equal to negative log of hydrogen concentration, and I'm just going to plug in 8.5 wherever I see pH. So 8.5 equals to negative log of hydrogen ion concentration. I'm just going to go ahead and solve for the hydrogen ion concentration by first dividing the negative on both sides. So divide both sides by negative 1. So I have negative 8.5 equals to log of hydrogen ion concentration. Converting this in exponential form, so this is 10 to the power of 8.5 is going to equal hydrogen ion concentration. So 10 to the power of negative 8.5 equals to my hydrogen ion concentration. And I'm just going to go ahead, I'm going to evaluate that on my calculator. So bring out my calculator. There it is. So 10 to the power of negative 8.5, that equals to 3.16 times 10 to the power of negative 9. So it's 3.16 times 10 to the power of negative 9. And that is my hydrogen ion concentration. Okay, great. Now part C of the question says, how much stronger is an acid with a pH of 1.9 than an acid with a pH of 3.8? So I'm going to be comparing their acidity level when their pH is 1.9 along with when the pH is 3.8. So I'm going to go ahead and calculate the hydrogen ion concentration for each one of them so that I can do that comparison. Okay, so for part C, I'm just going to focus on pH equals to 1.9 first, and I'm going to go ahead and calculate my hydrogen ion concentration for that part first. So pH equals to the negative log of hydrogen ion concentration, that is 1.9 equals to negative log of hydrogen concentration. Converting that into an exponential form, that is going to be 10 to the power of negative 1.9 equals to hydrogen ion concentration. Now I'm going to do the exact same thing with a pH of 3.8. Okay, so 3.8 equals to negative log of hydrogen ion concentration. Divide both sides by negative, so 3.8 equals log of hydrogen concentration. Putting that in exponential form, that's going to be 10 to the power of negative 3.8 equals to hydrogen ion concentration. And since I'm doing a comparison here, I'm just going to go ahead and figure out how much stronger of this acid is in comparison to that one. So in order for me to compare this, I'm just going to go ahead and I'm going to divide the two. So 10 to the power of negative 1.9 divided by 10 to the power of negative 3.8. And when you're dividing that has the same base, you can essentially just go ahead and subtract your exponents. It's going to be 10 to the power of negative 1.9 minus negative 3.8, which happens to be 10 to the power of 1.9. And when you plug that into your calculator, that is going to equal approximately, I'm just going to go ahead and plug that in my calculator right now. So I have 10 to the power of, sorry, I just can't do that, 10 to the power of 1.9, that is 79.43. So I'm just going to write it as 79.4. Okay, which is approximately 80. And just writing down my final statement, so pH of 1.9 is approximately 80 times more acidic than the pH of 3.8, as you can all see. So therefore, pH of 1.9